All right, today we will do the review of the iPhone apps development framework that we discussed and compared with Android apps development frame. And we'll start the coding in Xcode Swift today, okay? So mobile devices. The device has enough to hold and operate in the hand. That is the specification of the mobile devices. If we say mobile devices, it can be a smartphone, of course. That's what we are going to work on. In addition to that, there are many others. Tablets, even laptop computers, smartwatch, electronic readers. One of possible electronic reader is RFID reader. The implementation and application for RFID reader is here in New York area. If you drive, then you have a easy pass at the toll on a few the checkpoints where there is a RFID reader, and your car also has a RFID the tabs. So for example, if you come to the Manhattan area during the weekdays, then they charge you, right? I think $9 once you come in. If you come in twice, then they maybe double that. And many others devices that you can see here. Principles of a mobile app development, that is user-centric design. That's what we need to do. And then performance optimizations. Mobile apps should be optimized for performance. The loading time should be, it's not really tolerable. It should display on your screen within certain limited time, right? And your smartphone apps has various navigations, which means from one view to another view, depending upon your application logic, may navigate. So that should be implemented smoothly. And also efficient use of device resources. If your device consumes dramatically because of a specific application, then that application may not be the ones that you can say, oh, this is well developed, right? That should be fixed. And platform compatibility is not over the course of two different the major stream of the development framework. It's not like there's no compatibility iOS and Android. But within iOS, iPhone, the physical device evolves at least once a year. Then your application should be migrated accordingly, smoothly. Security, of course, this is very, very important. And scalability. Apps should be designed to handle growth in user base and data volume without sacrificing performance or user experience. Scalability is a good thing. In this semester, this class, I think maybe 2 weeks from today, we dive into the implementation of iPhone apps. The first the application that we are going to work on is user verifications, okay? So simply user can be verified from your hard-coded credentials, which is definitely not recommended, but that is something that we can start with. And then the other one is, since each device has the database already built in. We call that SQLite. So why don't we use that SQLite? So your credentials may be stored in your SQLite database, and the verification, your login can be verified based on SQLite's credential data. Thirdly, which is really exciting, and that is to use the multiple the computing resources over the networkings. So remember that we have the cloud server where your sensor data and your sensor image data stored. So your iPhone app needs to download the sensor data and sensor image data on your iPhone applications, and we're going to, first of all, how we can download from the cloud server. And the next step is how can we render the data and also the sensor image data. How can we scroll if data overflows the one view, then we scroll it vertically, right? Vertical scrolling is very, very common in not only in iPhone apps, but your laptop can be scrolled vertically. But iPhone apps, smartphones, or even these days, for example, if you use MacBook, then you can scroll horizontally. So horizontal scrolling, that is also possible. And functionalities, offline functionalities, and regular update and maintenance. CI/CD, that is very, very important. And then feedback and iterations. And simplicity, keeping the app simple and focused on core features help to avoid overwhelming users and improve usabilities. Testing and quality assurance. We're not actually going all the way through. I think we're going to number 1, number 2, number 3, number 4, maybe number 5, right? All others, that is beyond what we can do in this one semester class. Compliance with the guideline. Each the company, if a company wants to develop the smartphone apps, then they first define the guidelines and some regulations based upon the company's the business policies. Then your iPhone apps should be complied with the company's guidelines. Okay. And then the analytics and monitorings. Okay. Although we did this last week, I'm going to review comparison between iPhone and Android apps. First of all, language difference that we looked at, right? So we're going to work on here in this class solely a little bit of Objective-C. We don't really do this much, but Swift, yes, this is what we're going to do. Android, usually Java, but these days Kotlin, that is also a popular language for Android apps developers. And the developments environment. iPhone provides the Xcode as a UIDE. Android has Android Studios. And user interface for iOS. Then we are actually two things that we are going to work on. UIKit and SwiftUI. We will jump into that two different user interface today, so you can enjoy it. Android has also similar things. Android's store their UI specifications on XML, but that's not the case for iOS. Fragmentations. Apple has a small number of device model compared to Android, resulting in less fragmentations. We don't need to really worry about this, right? Android has a highly fragmentation. App distributions. For iPhone apps, only exclusively through Apple app stores. But the developer can enjoy to deploy the app that developer developed on the developer's iPhone. That is individual and manual deployments. It's not really the public. Market share and monetizations. This is something also a little bit beyond what we need to do, but this is something that we can see the difference between iOS and Android. Okay, Swift on Xcode, that's what we are doing today. That is a language, and IDE, that's for Xcode. Programming patterns, like many other languages, Swift has variables also. Variables are always initialized, like Python. So somehow, in this context, Swift is an easier language. Array, like many other languages, it should be within that bounds. Integers checks overflows. Optional and explicit, the value will be checked in iPhone apps. That's, for example, it's your null value. Nil values are handled explicitly. Memory management can be done by automatically, like the recent languages, Python, that's automatic memory management, Java as well. But C, memory should be explicitly allocated and also manually explicitly deallocated. So memory needs to be managed by the language itself. So somehow, because of that, C language is powerful. Because of that, many other languages are easier to use, like Python and also Swift here. Error handlings allows some errors already defined by the language. I want you to recall Python's. Then Python has the errors, we call that exceptions, already defined. So sets of errors predefined can be catched. Also, you can define your own exceptions, your own errors, depending upon the business logic of your programmings. So you can use it. If you know Java, then Java is a lot more powerful, the exception handlings. Swift exception handlings is powerful, but most of the cases are well-defined. Large sets of predefined preset errors available in Swift, which is good. So you can download Xcode if your iPhone apps does not have. Then, did you receive MacBook from the department yet?
I wanted to talk to you about that. So I've been in contact with them. I would have to go to the office, pick up the MacBook and return it later. But I went home and I watched your lecture again, last week about like the state of development, mobile app development in 2025, and one of the options was to develop a React Native mobile app, and I wanted to ask you if I could do that. Instead.
Which ones?
So there was like iOS native, there's Android, and then there's like React Native. So basically, you're doing React Native, and you're developing the app on this Expo thing, and it translates. It's platform agnostic, so
No.
it translates to iOS and Android. It's still a mobile app.
I know. Then you are completely away from the content that we are
I mean, it's still
working on here.
parallel, right?
It's not, yeah, it's not Xcode. It is not Swift. So I'm not sure how much that you can learn from this class if you go for that. Why don't you check it out? Why that is the problem?
Oh, I mean,
That is free for you.
the MacBook.
Yeah.
Well, I would have to go to the observatory. It's just a lot of work to go up there to pick up the MacBook and then do it again at the end.
You can ask them to send you.
I don't think that was an option. They said I would have to go pick it up in the email. Yeah. So
They can do. They can ship you out. Only the issue, then there is a mail errors. In my other class, this time we sent out, for example, Raspberry Pi, but one student gave the wrong address, so we lost one Raspberry Pi, and then we sent him again to the right address, so he received it, but he broke that Raspberry Pi. So that type of things. So once you don't follow, then you create a lot of problems. I hope that's not your case. But anyway, so yeah, it is. I'm not sure. It's a one-time travel. Why it is?
I also would like to learn React Native more because I think it's.
I don't
better.
teach you that.
Yeah. Well. I can still.
This
make a
class
little
is
bit.
class. For example, if I teach you Python, but if you say, hey, I'm going to learn C, then
Yeah, but-
what is the point of
Well, I
the
still
class,
learn
right?
how to work with the sensor. I still make the project for the class. Teaching myself, I'm still learning.
No, that's not.
It's okay. I'll do the iOS app instead, and if that's a hard requirement for the class.
Yeah. Okay, so you can install it on your Mac. Mac in Cloud is something that you can do, yeah, but that is not recommended, but that is doable if you want to work on the web-based. It's called Mac in Cloud. I think it is on now. As Nam said, it is sold by Amazon, right? It's not Apple itself. But a long time ago, Apple directly sold it. All right. So you have to learn the language Swift. I'm not really teaching you Swift itself. So of course we do not have enough time, right? You guys can learn directly from the application that we are working on, right? So it is quite possible. You don't have to learn language itself separately from the implementations. So rather than we directly work on Xcode. So actors, Swift is an actor, and Xcode. The current version of Xcode is, I think, 16.2. That's what I installed a few days ago. And device, Apple TV, and you might have Apple Watch or iPhone. But we're going to work on iPhone. Our target, the mobile device is iPhone. You don't need to have an iPhone device, but Xcode provides you emulator. So we're going to use an emulator most of the time. So Xcode. Xcode provides you playground, so you can For example, if you want to make sure that certain language, certain statements, Swift statements, then you can start a playground. So you need to choose Swift playground apps. We usually choose these apps for our app developments, but playground, namely, that is the playground that you can initially make sure some of the languages, some of the statements more clearly, explicitly on your own, not just related with the applications. Then you can play with this there. Sometimes I teach the language here, but it is kind of not useless. It's useful for those who do not really know about the language itself. But our program requires you to learn Python. Once you know Python, then Swift is not really much different from Python in coding technologies. It's like the language. Once you speak English, then you can speak Spanish. The way that you can form a sentence, then you can say, hey, I want to make a sentence. So give me some of the vocabularies of Spanish. Then we can make that, right? So it's something like that in the codings. So I want to skip the playground, but we jump into the real implementation. That way you can learn faster. Concepts remains the same here in Swift, like many other languages. Functions, definitions, and invocations, a little different from many typical languages. But once you know the difference, then you can get it, right? That much I always point out. Parameters and arguments needs to be handled properly when you define function, when you invoke functions. So Swift is that way a little different, but that is I would say a little bit more powerful because of this in Swift. Iteration possible, conditional statements, variables, operators, types, initializations. Sometimes you need to initialize, but many cases you don't need to. So if you start with the playground, it's just like this. Okay. Why don't I give you that? To start Xcode, if you install it successfully, then you can start from your application folder, or bottom. I have that Xcode here, so you can. Here's something that I already have. If you develop some of the apps already developed, then you can see from the recent ones. I don't think they list all that you have, but some limited number of applications listed on this right hand side. If you start first, then you can do here create a new project, or you can get some GUI. I mean, not what is that? Yeah, GIT, right? You can clone some repository. We don't do this here. We simply open existing project or creates in this class. So we create one. And this recent version of Xcode, we have here App Playground. But earlier version, for example, last year, doesn't show here. So we have to first create apps, and then we need to switch a little bit inside. but they show it here. So we click this and next, and then you can say this is a playground test. I usually do, if it is playground, my app can be named starting with the playground, so that I can see, oh, this is playground. And then you see test 1. And then team, you name it as you name. Then the organization identification will be that name, johnyun.com, but in reverse order. And then next, and then you need to choose where you want to save this. So in this case, you need to create a new folder. So I created already. So class 25 Spring, and create it. Then you have new playground. So we can practice a little bit of these things. Yeah. Here's my app. If it is a SwiftUI, then it always like this. So this is not really playground. This is a little bit advanced. Why it is? This is just new. I believe this is, they changed my app. Content view. This is my app. This is good. Okay. Well, actually, this is not really the playground. This is not like the previous playground. It's like the real app that you can see here, right? Real app. So then we don't need to do this. We are going to real app. Not, I'm going to close this. So usually when real playground provides you, it was like this, but the recent version, playground is not really playground. So I'm going to skip that, and then, yeah, this is playground. I'm going to give you a little bit of the Swift languages. It is like, if you know C, this is a little bit similar to C. Start with the struct, like a structure form, and the name of that struct, colon, followed by type. So for example, if it's a content view, then what is the type of a content view? That is the view. Okay. It is very similar to object orientations. So content view is a subclass of view. In object orientations, your class, once you define a class, then that class itself can be a type. Okay? So type view is already defined by Swift. It is not, don't need to worry about. Because view is very, very common in apps. So view is already, I mean, big implementations as a class provided to you. So we simply use it. So you can think in one or the other, I mean, two ways. Content view is a subclass of view. Content view is a class, like a class similar to struct. Content view is a class, but that is a subclass of view. So you can interpret this in object orientation. Or another way, content view is like some of the frame, some of the struct in C language, but type of this struct is view. Okay, like character, that is a type, right? Character is a built-in type. In this Swift, view is also a built-in type, but that is not the type that we can see in typical programming languages, like Objective-C or C, Python, Java. There's primitive types that we can think, right? Like string, integer, double type. Yeah, those are the primitive built-in types. But this is, again, type, but that is very, very powerful and implemented for many powerful features. So you may see this kind of code blocks a lot. So let's do this. Users struct block of view to play code in the body, which returns some view so that you can see it. Some view means, see here some view. So this is in the body. And then we call that some view. The language some view means the body will always be implementing the view protocols, but the concrete implementation type does not need to be known by a caller. So we don't really, we are caller, right? We simply use it. The view is already defined. So we invoke that view. As a caller perspective, we don't need to worry about all details. If you want to worry about all details, then you need to join the Apple company and also join that Swift development teams, right? Then you develop that view. That is primitive level of developers. We also kind of a developer, but we are trying to use something developed by that primitive level teams. That's what this guy is talking about, right? So we simply say some view. So variable body declared here. So what is the type of variable body? There is a view, but it could be some view. It's funny languages, but anyway, this we do this. Okay, these two lines that you can see, many cases. Therefore, that two code blocks needs to be closed accordingly. So inside here, that is your implementations. SwiftUI is Apple's modern framework for building user interfaces. Not like UIKit. Although we are going to touch each one of those today. Maybe next week, then we need to see how we can combine them together. In the case that if we want to see it, I want to work on SwiftUI, but some of the user interface not available in SwiftUI, therefore I need to use UIKit. Then we need to import both to SwiftUI and UIKit. So SwiftUI, that is a declarative syntax. And cross-platform, meaning not only your smartphone, but many others device types available from Apple. State-driven. Automatically update UI when state changes. This is a very, very, very beautiful feature that you may see even today, right? We don't have to a little bit of this is a big advancement if you understand a typical programming language like Python. I guess you guys did a little bit of when you took Python languages, then the graphical user interface. User interface also developed there. Then one of the event is some of the UI handlings, right? So you click buttons or you enter some data into the text fields. Those, in response to that events, then your code needs to behave for some of the updates, right? So in your code, you have to do when this button is collected, then you have to, hey, we need to do this. Some of the actions needs to be specified. But in Swift, this is a data state driven. Data state, if data state is changed, then that UI can be also accordingly updated. Okay, this is really handy. Seamless integrations. This is the feature also. So live previews. So first coding in Swift automatically that you can see this, right? So for example, if we open up Xcode again, here, by the way, I need to delete that. Here, this is playground. I don't need to do this. So I need to delete it. Create new project. So this time, click on app, open. Now we need to say my first app and team and interface here, SwiftUI. If you look at here, the two interfaces, storyboard and SwiftUI. For this, my first app, let's try with SwiftUI. And the language is Swift, of course. If you see here, then yeah, Swift only one language. Testing systems, I want you to put none. Storage also, if you want to use the core data, that's what we want to do for our internal database. But I want you to click both nones. And then language is Swift, interface is SwiftUI. Okay, and then click next. Then it asks you to where you want to save. I want to save it to this folder, create. This is given initially, right? So I'm going to explain this code. Although we did a little bit of those, right? On your right-hand side, as you see here, that's shown, right? Beautifully. That comes from here, this preview. I think some of the features that we looked at it says a preview is possible, right? In the previous slide. Yeah, live preview. That is what it means. That comes from this language. Less than 3 lines of this. Pound sign preview. In that preview block, code block, it says content view. So content, what is a content view? Content view is the class, like a struct that we define here. That is a content view. So this guy says, hey, I want to preview the content view. So if I comment this out, all this, then my preview disappears. Unfortunately, Malik, is it your Malik?
Yes.
Is it your MacBook or?
Yes, MacBook.
Oh, are you following me? Nam.
Yeah.
Are you going to get MacBooks or?
No,
Because
I'm
my-
going to virtualize it. You
Because
can't, you just can't
I want to, when I teach you, I want to see if you can follow me, right?
Yeah, I'll do the Swift. I'll do the Swift UI.
Oh, okay, good.
Yeah, I'll probably make it with Swift.
Right.
Maybe UIKit. Can I do UIKit at all? It has to be.
Not right now. We'll do it. We'll go back to.
Okay.
Because no one's really see when I show this. Usually when I show this, then they need to be the same feelings. When I commented this out, then we see here we have a previews immediately, right? When I comment out, it's out, right?
Yeah.
And also, you guys need to show, hey, Dr. How come you can get all the comment that quick? Comment this out. Comment this on. How come you make the comments so quick? It happens most of IDEs, right? So highlight them, and then if you are working on, for example, Java or Python codings, then you can use Control key. But for this Swift, then you're holding down Command, and then slash. If you press slash, then all that entire highlighted block can be on comment block. Okay, that's just a tip. So if you have this preview, then you can see the preview on your right-hand side. You can resize this back and forth, right? And sometimes if it is stops, then you can click on here, then it can be rerun, okay? As I said, these two lines of code blocks I already explained. This content view is the name over here. By the way, if you see these screens, then on the left side, this is a navigation pane. Then on top, there's my first app. This is my first app. Then you can see here general information about you. My OS is 18.2. And then signing and capabilities. Then you need to register you. And then the bundle identifier is starting from com.jongyun. This is my actual name of these applications. You can so you can register as a developer formally. Then there is annual fees charged that I am doing. I think there's a little bit over $100 annually, but you don't need to if you are not working on this seriously. But for computer science developers, I think you need to do this. I strongly recommend you. Then you will get, you don't have any issues. But if you have a temporary IDs, then I'm not sure what would affect you later. Resource tag and all others. Some other cases we needs to touch this, but not this time. For example, info here, if your app needs to access the internet by default, your app is disabled to connect to the internet. So we have to set that features here, info, when it comes to that, but not today. So on top of this, then you can see some of the configurations by looking at the tab up here. And very on top, then you can see there is a the emulator that you can choose. Okay, I chose iPhone 16 Pro. You can include more and more as you wish. So this is a iPhone 16 Pro. And if you unfold this, then you can see the package name. This is project name. One thing, this is very, very important to you guys from today, of course. When you submit homework assignments, let's say if this is your homework, then you need to come back here. There is it. You save that on this this folder, right? On this folder, class 25S. This is my program. Okay, that is this. I want you to do not submit any of this, but I want you to come back here, your folder. Okay, when you complete it, then this, everything about that top level, you need to compress it. There's a compress called compress. Click that. This zip file needs to be submitted. That way I can evaluate it at my site. If you submit this content view or any specific the files, then it's not going to work. My cases. All bundles should be submitted. Question?
I was gonna do the view design with Figma. Is that okay to just submit pictures?
I cannot evaluate that. I cannot rerun at my site.
So you want us to like start with Xcode?
Right. Only right, because I'm using Xcode. I'm not using any other. There's only way that I can evaluate yours. If you use something else,
About homework 4?
Yeah, homework 4, right?
It's talking
Sir?
about homework 4.
Or are you talking about the next homework?
The one for the UI UX, we need to give you the sketch.
no. That's
That's a sketch. Oh,
That's a
I'm
sketch,
sorry, I
right,
was talking about
yeah.
that homework. That's due today.
right.
Can you
From
use it-
today, yeah.
Can you use that sketch app from the App Store? We just draw the app.
If you are working on UIKit, you could do that, but we're not going to continue to work on UIKit. You will see what I'm saying.
Well, I think.
That is available on UIKit only. But we're not, from this semester, we're not going to work with UIKit. UIKit is easier to start because you can drag and drop. It can visualize it very nicely. You think, oh, it's very nice from this view to another view, systematically that you can see it. But that is not professional development scheme. SwiftUI is the direction. A couple of years ago, Apple announced, I think 2 or 3 years ago, they said, we're not provided any more UIKit. We're going to stick to SwiftUI. But they stepped back a little bit. I think some of the community says, oh, we still need UIKit. UIKit is good for you to visualize it. We're going to work on, I'm going to let you know how you could do that. But the language is similar, but all navigation schemes completely different. All the navigation means from one view to another view and coming back from there. All those things in SwiftUI only by codings. SwiftUI, to drag and drop from here, there, and then you need to set another utilities panes. What utility pane means here, by the way, this is the navigation. This is your editor, right? Codings. If you, on top, the most right corner, if you click this, then you can see some of the utilities. So if you click some, that you can see, but those are very useful and required if you are working on UIKit, because everything not on your coding statements, but drag and drop, you need to do. But remember that I have here import SwiftUI. Right now SwiftUI only, so doesn't show that. We'll get back there. So here, if you unfold that, then preview content. This is preview content that we can see, right? The packages, my first app contains preview content, asset. Asset is something that if you want to add some of the pictures, so picture needs to be shown on your iPhone apps, rather than download from the cloud. So we practice two things. We can explicitly save our picture on our application, so that picture can be displayed. That is too easy. The other one that we are going to learn is we're going to download from the cloud. Remember that you guys already posted your sensor images. There's a whole purpose that I ask you to do, right? Sensor images, I checked last night, your sensor images is really there. Yeah, it is really there. So we can download that images on this app and display that because you might have multiple images. So you're going to make it horizontally scroll or vertical scroll, that type of things discussed. That's for asset. Asset is explicit and manual image insertions. Real, the coding files, we have by default two. Okay, this is a name that I already made, right? My first app. And then it has another, say, app. App is, the first app is, I named it, my first app. Whenever you say, for example, travel to Europe, that is the name of that app. Then travel to Europe app. That is a file automatically generated. Here, you don't really generate this, right? This is given. So first the app, colon, app. Now we understand what is this. So my first app is like a class in Java, for example. Type of this app is app. So app, there's a class already developed by Apple teams and provided us to use it. So we simply use this, right? So this is a class, this is a superclass. So when you define a new class, then you always say, in object orientation, there is no single class that's name. Would you be able to name? Would you be able to open? Thank you.
Professor.
Traffic?
Yeah, sorry for that.
Fu, by the way, what is your heritages?
Sorry?
This your name is.
My name.
I know Fu from right? From.
Yeah, you can call me Edward.
From Edward.
Yeah,
Oh, that's a good name.
thank you.
So where are you from?
I'm
This
from
name.
Vietnam.
Oh, is it a Vietnam name?
Yeah, that's Vietnam name.
That's not similar to.
It is in many ways. It's just weird.
But your name is more.
Yeah, well, yeah, it's similar. You know, it's like if you have like two Korean names, you wouldn't be able to tell if they're similar or not.
No, I was is. This is more
More difficult.
more Vietnamese
Oh, yeah.
names, but name's name
Oh,
more toward the Korean name or Chinese name. Okay, I think some South Asia's Malaysians, Thailand sounds like this, right?
No, I think
No,
different. Yeah.
quite different to me.
Some similarity. I know, like I think Kim is a Korean name, right?
Right.
That's a Vietnamese name as well. Yeah, the people named Kim. Yeah.
But Huang, your
Yeah,
first name Nam, that's very common in Korea and China, I think.
Really? Oh, it's quite
Yeah.
common in Vietnam too.
Yeah.
Actually. It's a
Nam?
common name in Vietnam.
Yeah, no.
But there's no name like Phong in Korea.
Actually, my first name is Luong. 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 That's my first name.
Yeah, I think.
Oh, what is a food then? PHU?
PHU, I'll say it kind of
Like PhD?
like a middle name.
Oh, PHU is your middle name?
Yeah, but they do not consider it as a middle name.
They being who? The college?
Yeah, the college.
That's strange. You might want to figure that out with the visa and whatnot.
Are you from South Vietnam or North Vietnam?
South Vietnam.
You are South Vietnam.
Yeah.
Oh, Nam is from North Vietnam. So, is it the reason?
No, I don't think so.
It's not the reason.
I don't think so.
Yeah. Yeah, recent days I read some histories, Vietnam histories, because I have students. Yeah, very interesting histories between Vietnam and China. Yeah,
Yeah, Vietnam and China as a whole can of
yeah.
worms.
Very similar to Vietnam, I mean Korea and China.
Similar.
Yeah, similar, but yeah. But I think Chinese is stronger than Korean, historically. When I read some histories about your Vietnam. Okay. So you interrupted me. Okay, this is the name of that, and this is a class. So in object orientations, class cannot stay alone. In object orientation, when you create class should be belonging to something already defined. That is typical object orientations. It's not really the case in Python. Python is a little bit like toy-like language. That is the reason. But if you go with C++ or Java, then you always say, when I create a class, then class needs to be under something, because it should be defined based upon some templates. So we call that superclass. So superclass is app, and then there is a so in object orientation classes, there is a class hierarchies. That class hierarchy is, for example, in Java, is visible. It is well known. In Swift, hierarchy exists, but usually we don't really care much about that hierarchies. Not like in Java developments. But anyway, this is class, subclass to this app. And then we declared a variable, body. Therefore, we can implement something in this body. So body, when I create body, then may ask, what is the type of body? Type of body is some scene. Scene is another class already defined. But as a caller, we don't really need to know any specific scene, so we can say some scene. And all in between, that is, that is the body of that, or actually body, because it is said body. So in this body, you say here, Windows group, that groups this class content view. Content view is another class here. So this guy tells me, if I click this, start active scheme, when I click this, then this guy works. This guy, if you do not have this, then you cannot bring this emulator. Because you have this, you can emulator. And then, by the way, there is a @ and main. This can tell you that, hey, by the way, this is, because of this is entry point. You can relocate that @ main in another. If you have so many, you end up having so many the files, right? At some point, hey, I do not want to start always here. I want to start from some of the midpoints. Then you need to remove this main, the @main. You can declare this @main at some other places. Then when you click this to emulate, then it starts from there. So this is a starting point, entry point for emulation. So when I click this emulation buttons, because I already set here iPhone 16 Pro, that'll come out, right? So I click this. So this is iPhone emulator. So this guy says, this is this emulator descriptions. In this description, it says, hey, I want to display content view. So this guy does not, this itself does not say anything about that content. So let me push this away a little bit. And then if I go back to this content view, then I may be able to see. Even if I comment this all, still I can see that visualizations, that emulations. This one is just preview. So I don't have any preview there. Here, I want to close this. So if you see the code block here, that we already looked at this. And then it has two things, image and text. Image and text, that is also the class already defined. So this is an object constructor. See, in object orientation, this is class name. This object can be constructed. If it is a text, then by giving text, that is constructed. If it is image, then we need to give images. There are many different ways that we can give image, but image that we can get from system name. So we can call globe. By the way, this is global, right? And this is itself is a class constructor, which it means that is an object, right? If it's an object, then object can activate functions in object orientation. We call them method, right? Because this itself is an object. Object and method can invoke a method that is already defined, right? So one of the methods here is the image scale. So object dot method, so dot notation is used. So as you see here, this itself is a dot notation, right? So I wanted to figure that out. This itself, because this is object constructor, the highlighted here, there's nothing but an object. Because this is an object, this object can invoke method already defined in this image class. So image has defined the method called the image scale, foreground style, and all of those maybe directly defined in that class, or the method probably inherited from above. If we see the class hierarchies, then along that class hierarchies, image object may be able to access and also invoke a method which is available from that inheritance. So image scale, that is a method, and another method is a foreground style method. One thing very, very powerful here in Swift, if you compare that to Python or Java, Python or Java, then object dot method, that one time that can be valid, right? Unless that method returns another object, then we cannot use object dot method dot another method dot another method. That may not be possible. But here, Swift, that is possible. So this is very handy. So these image objects can invoke dot one method, another dot, and another method. This dot second method not related with the first method. So this is an independent method. So all dot dot multiple dots, even if you do more, those dots are, for example, if you put here dot padding that you need to make is some gap, right? So if you see this, if you have a paddings and then re-emulate, see this is they are stick together, globe and hello world, right? But I want to replace that. See how it can be emulated. Oh, a little bit, right? So we have some of the paddings. That's what I'm saying here. So this method effective to image objects, and this method also effective to the same objects, and this method is effective to the same method. So all of these methods directly effective to that objects. Okay. Because I said here stack, but vertical stack, so they can be vertically stacked, right? So I want to bring that preview here so that you can see that effects immediately rather than emulating all the way here. this emulation, as I said, it directly go to start from this main point, whatever that this main point point out. Here in this case, we need to do content view. Then it goes to the content view, and then finally the content view is visualized. That is this emulator. But here preview, we don't need to do. We can see that preview immediately, right? So not automatically do that. If it is that, then we can click it. Yeah, and also you can make it smaller if you want, and larger, smaller, and smaller. If you want to make this rather than V as a vertical, if you want to make it horizontal, you can do that. If you put here H, or in this case, this automatically preview, right? You have a globe. On the same row, you have the text. These things is the beauty of the SwiftUI. If you are working on UIKit, then you have to drag and drop horizontally, vertically, manually. But in SwiftUI, you simply change that language from H to V, then that is vertically. So that can be automatically preview. Any questions so far? So let me close this. Stop that emulations and we can go. Okay. I think that's what we did. Okay. So I'm going to go to hands-on. I have another one here. This is hands-on today. So we're going to work on two things. The same ones for two different ways. One time that we use storyboard, the other one is SwiftUI. Okay. So if you are working on UIKit, so-called storyboard, then always you have to define two files: storyboard view and controller. Controller is a coding. Story view is some of the layout. So layout visualization. And then these two things needs to be connected, right? You define this separately and then connect them together. That way, you have multiple view controllers, multiple story views, so that you need to say, hey, this controller is the file controlling that view, and another controller file controls another views. That things needs to be defined. So in this is for layout. This is something visualization, right? This is a coding. So this visualization to these codings, drag and drop UI into view controllers. So using that UI within these codings, then you need to do some of the logics in that codings. That is what we can do using UIKit interface. We'll get to this. Okay. Then this is what we want to do. So enter your messages, and then we have a text field, and then we say echo me. So whatever that I typed here, and when I click this, then at some place you echo it. Okay, this can be echoed. So we will work on this at one time using UIKit, at another time using SwiftUI. So this is a SwiftUI. That's what we do, like this. Okay, see here, we see the previews. And when I click this, when I type something, click, then it can be displayed somewhere. So two things that we need to do. Okay, this is more the language itself. If you see this view controller, remember that this. I'll show you. this is a storyboard, right? This is a storyboard that we need to use this utilities and using this UI libraries. We can drag and drop some of the text fields, some of the buttons, some of the labels, and another hidden labels. And you created how many UI components? 1, 2, 3, 4. 4 UIs components, right? And then this is my controller. This is my view controller files. So I need to bring 2 side by side. So one for that storyboard, the other one for that codings. So we need to drag and drop this. So my coding list can understand this visualizations. Okay, here I already said this is a UI text field. This is the class already defined. My local object is TF message. This is my variable, and another variable that I created label echo. TF. This is I named it. My convention here is if there is a text field, then when I name the variable, I usually use TF for text field, followed by my variable. So I call that messages, TF messages. IB, there's a label, and this is my variable. So label echo. And button, if it is a button, then I said btn for button, and my actual name for that button is echo me. All right, so they are connected. And then this is already done. This is already done by drag and drop. This is already done. Inside, only I did this. And I said, this label echo, that label needs to get some text field. So we can say, using dot notation, dot text. Into this dot text, I want to get another here from user enter the text field. Also, I can get the text from that user entered. That text needs to be assigned to left-hand side here, echo field. Then it can be echoed, right? This is by click this button, then if this button is clicked, then inside whatever the statements that can be activated. In this case, only one statement. Okay, that is UIKit. SwiftUI, you see that coding list, right? SwiftUI coding list is a little different here. Here, echo SwiftUI. I believe this is that file tells you that file has a tag say, hey, this is a main file. So when you emulate your the project, then this is the file that you start with. Then you can say that @ and main, and then in this description, it refers to this control view. So this is the file. If you see this control view, then as we looked at, this is a struct and control view that is a subclass of view, and it has a body. This is the view body. The body is a some view. Inside this is the implementation. Outside this, we have variable declarations. We have a TF message and echo messages, 2 messages. Type of that string. Okay, so this message contains the string, and then echo message that is also string. Initialize both empty, and then we say here state. That state I explained in the next slide. So what is state? If you want to say variable is owned by view itself, then you can say what is. If these variables are owned by me here, content view, then we can say state. Another one, if the value changes dynamically and automatically, therefore, if UI needs to be updated, then you need to say state. So look at this specifically, the second variable, echo messages. Echo message, there is a variable, we call that state also. Look at here. This is a text field, the first text field here, right? We can say enter your messages, and this is a real text. This, when user enter text, then that appears here, right? So text is nothing but this first variables. So when user type, then it can be fill in this text field, And the other method say I have a padding, I have a text field style. This is another method. Style, then we have another, the value there. There's a rounded border text field style. So we assigned that to that style. Therefore, this one can be styled that way. And then entire, this is a vertical stack. So next line is a button. We have a button here. I call that echo me. And then when you click this button, then user entered the value needs to be another value, echo value. So TF message is assigned to echo messages. And the others are simply the method invoked to visualize the button itself. For example, background color, foreground color, and the corner radius. This is not really the 90-degree sharp corner, but some of the round corner. That's what this guy decorated. And then finally, we have a text. Another text here is not shown, right? Text, we show that this one, echo messages. And this is a font, and the other is declarations, right? So actually here, text field, button, and text. In the text, we don't do anything, right? When the user enter value, then it can be shown here. What this means is when data state is dynamically changed, accordingly UI can be changed. That is the beauty of this user interface in Swift. You don't really say, hey, if this button is clicked, then I want to make a text, therefore there is a, the user entered value can be displayed. It didn't say that. We simply declare, hey, first one is text field, the next one is a button, and there's a text. This button has implementation in it, assignment. This assignment is assigned when this button is clicked. Then this variable, this is the data, right? Data state is updated when this button is clicked, because this guy says at that time, value is assigned to that. Data is changed only this button is clicked. Data is only changed at that time. Because of that data change, automatically, accordingly, this data states if there is another data, if that is related with that data changes, then that UI can now accordingly update it. What that means is that previously this echo, initially empty, is displayed. So you don't see it because that is empty, right? These 3 lines of UI, these 2 things that you can see. This is you cannot see because empty. By click this, you don't do anything to this text field. You click this button only. What this button can do is this button only change the data. Because this data is changed, and because this UI used that data, therefore, finally, that text can appear. Right? I think I explained that. Okay. So now we need to start. We need to see something like this here. Push this a little bit aside. Okay. So I want to see 2 projects called Echo UIKit, Echo SwiftUI. Okay. So create applications. Next, and I say here echo underscore UIKit. And then interface here, that should be not SwiftUI, but storyboard. Okay? Because we are using UIKit. You need to do storyboard. Next. And I want to save this in class 25 Spring. create. Now I have this. This is a top level. The project name, Echo UIKit, and there's a package, Echo UIKit, and then there's two files, a main file and view controller. Main file and view controller, two things that we are going to work on. So first the main controllers. Then you need to do here, I want to bring up some of the show library. From the library that we need to bring that UI here into your view in this storyboard. So there is a plus sign, library. Click that, then you have a label. First of all, drag and drop all the way here. And then you can bring that utility pane by clicking upper right corner. Click that. And then there is a call that this is a label. Text plain. This is called the label, right? So you can delete this, and then you can say enter your messages. And then don't forget to hit return. When you hit return, then you can see the change of that, right? You can change it that here, or you can directly change it here. By double click it, then you can say enter here. You can do that. You can bring this place anywhere, like this. And you need to click this plus button again to choose UI to bring it, right? If you want to design this storyboard with the multiple UIs, then you don't need to click this one click at a time, but I want to click this and stay here, not disappear. Then holding down option button and click this, then it'll stay there. So I want to move this a little bit here, and then I want to bring button. No, I need to first text field. If you do not see text field here, then in this search text field, you can say text field. So you can drag and drop this somewhere here, and you can make it bigger if you want. And currently this outline is not really visible. So on this utility panes, there is a border style. I want to make a border more solid lines. Then you can see that that's solid lines. Even if I bring this text field, you now see this remains, this library remains, right? Previously when I drag and drop, immediately disappeared. So now you can do here a button. So you can bring this button here. And you can say double click and then echo me. Enter. If you want to a little bit of this, for example, if you want to change the background of that button, then scroll that down, view, there's a background. If you want to change the background, for example, whatever that you want. If you want to make it purple, and then foreground, then you can say there is anything that you can do. I want to do white color, so echo. And then again here, font style regular. If you want to make it bigger, for example 25, and done. This is not really bigger. I want to make it large title. You can do something. Okay, so when I type this, then click this echo me button, then I want to display it somewhere here, right? So then you need to get the label, another label. So type here label. So bring that label here. I want to make this bigger, like this, and wider, and centralize that. I don't want to show this initially. Then you need to put here empty and hit enter. Then it exists here, but nothing shown, right? Initially. So in this way, you can drag and drop some of the UI on your storyboard. This is one view, right? If you do not need any more for this library, then you can click this out. And as I said, this is a view, right? But you need to have some background view controller. Initially, there is a one foreground view and background file, which is called the view controller. Foreground, it is called the main, and then view controller. So view controller is already given, right? You don't need to define the class itself. But if we have a multiple of these views eventually, then one view, for each view, there is a background behind the view controller. There's a separate file names that should appear here. And then you need to link them. You need to connect from here view storyboard to that view controllers. So we need to actually more space, right? Then I want to hide utility, the inspector pane. So I have bigger. And then there is a button. Second row from top to right end, there is called the add editor on right. So if you click this, then I have two editors side by side. Left side, I have that playground. Right hand side, instead of this, I want to bring that view controller. So click this right hand side, and then choose the file from that navigation pane. We call that view controller. So that on the right hand side, I have a view. I have the coding list, and left hand side, I have a playground. Okay. And this is automatically generated. You see, there's import to UIKit. Class name is view controller. That's the name of this file. That is a subclass of a UI view controller. It is a method called the UI did load. This is a method. We call the function is a method. It's a method, right? In object orientation. So function that overrides, which means whatever that you implement here, that overrides from something that you inherit. View did load. So we inherit from superclass. So super object dot view did load. That is inherited, and you can do more here if you want to do more. Okay, some of the things, but we don't do. This is class, by the way. Okay. So that's what you can see here, right? So we need to connect. So how can you connect? Then we need to decide which one that you want to do in your codings. Are you going to do this title in your codings? You don't need to, right? What about this text field? Yes, you need, right? You need to read when user enter text, then you have to pick that text in your codings, do something further, right? So in that case, then you need to do holding down control button, and then drag and drop. So when you drop, you need to drop this in the right positions. look at this. This is entire from here there. That is a class, right? This itself is a method. This is a function. So you need to place outside this function, but inside this class. Some of the variables up here, if it is a the button is an action, because that's an action button. There's nothing but a function. So that can be like this function definition here. So that can be below these functions. That's what we want to do, okay? So two things that we have to, two variables needs to be declared. First one is from this text field, holding down control button and drag and drop here and release. And then make sure that is outlets and name. Now we need to name that variables because that comes from text field. I said text field, TF, and the message. And then type of that is a UI text field. Of course, that is UI text field, right? This variable is a subclass of a UI text field, or type of this variable is a UI text field. Okay, that is outlet. Connection is outlet, and then connect. There's a button connect. Then all of a sudden that you have that declarations here, right? You didn't type it, but you drag and drop, and you see this. This is a variable. Variable name is TF MSG. Type, that is a UI text field. That is interface builder outlets. This is some of the declarations, and we don't need to worry about that now. And then I know there is another label bottom here. So if you bring your mouse a little bit, then there is a hand buttons appears and disappears. Here, then arrows, mouse, then nothing here. But when you come here, there's something there. I know that is a labels. So holding down control button and then drag and drop here. I want to declare that label. So label, and then you can say echo. Echo text can be placed in that label. That's what I want to do. And then connection declaration is outlets, and then type of that is a UI label, and I want to connect it. So another one came here. So one text field and one labels, and then finally buttons. So control, holding down control and button. Button needs to be below that functions. Is it mandatory? No, not mandatory. In this way, you can read your code better, right? So bring that there. Connection should be action, right? It's called action, not outlets. Automatically, it takes actions. But some other cases we can do, even if that is an action, like a button, we probably declare that as a label, but we don't do that here, but action only. And then that event, when touch up inside, when I click and release it, then action needs to be taken. That's what it is. You can say here, this is a touch up inside or touch up outside, touch down. When you start to click, some action may be taken. Many different ways, right? But we don't change it, but touch up inside. So when you click inside, as you click, it doesn't do anything. Click and release, then that action is taken. I name it, so btn, there's btn for button, and then I can say echo. Okay, so from this playground, I used all UIs that are necessary for my codings. So I don't need this left side. Then you need to click the left side here. Very carefully up here, they're all highlighted, all others are gray, right? Something white. So which is definitely second row from top of this Windows. On the left end, there's X buttons. X button. It is called close this editor. Now I have the editor itself. So what I want to do here, if this is button clicked, then I want to put them there together, make it clear. Here, I want to take this TF messages. Which one that I want to take? From there, text. I want to take text. I want to take text. And that text needs to be assigned to where? LB echo, label echo. Not simply label echo, but I want to text it. So text it from there into that. Okay, this is the code. This is the end of that project. Here, if I emulate it, they came up here, right? Why the labels? If I say here, hello Mercy University, and then click this echo me button, then that's echoed, right? Hello Mercy University. Okay. I want to, maybe I need to change that label came up. Why that is? Oh, because of this. Why this? Yeah, that disappears. I want to redo. Yeah. Hello again, and echo me. That can be echoed, okay? This is the basic idea of using UIKit. Close this. And the next one is SwiftUI. So SwiftUI is only simple somehow, but at the first time it needs a little bit of the codings. So you can do application and then echo SwiftUI. And then make sure that this interface should be SwiftUI, not storyboard, SwiftUI. Click on next button, save it into that directory, and then I don't need this inspections, and it automatically show to me that. So what I want to hear, I want to put this here, text field, and then you can put here next ones, and then you can say enter your messages. Then you need to bind that whatever user entered, then you need to bind that user entered value into a variable, so that you need to say here, remember that state variables, so state, and then private variables. So very nicely. So we can, the variable name is not text. We can say text field messages. Very similar to the way that we defined for UIKits, right? We don't need, not necessarily TF message here because this is not a UIKit, but let's make it similar to that. So here, that should be at, and then that states TF messages. That's a text field. What this guy says. No. Maybe this is, we need to say string. text field. Expanded expression, list expression, missing the arguments. Not sure why it is. Okay, so text and then at. Cannot happen. Strange why this is not working. Text field. Let's try further. See, it works. Why previously it was not working? It takes time. Okay. And then we put here, this is a last text. Inside we have a button. So button, but then we can say echo. We can say echo me. When that button clicked, then we need to say these TF messages should be assigned to another messages, right? We call that another message that we need to define another variable. So we can say echo messages. This automatically pick that. Very handy. So it goes to echo messages. And here we simply, on the later text, we can say that is that variables. So echo messages. Right. This is it, right? We can declare a little bit more, right? So if we put here, hello, Morsi, and echo me, then it appears here, hello messages, right? So this is simple statements generates in Swift. But in Swift, if you want to decorate a little more, you can do that, like objects dot method, so that we have a dot method here, text field style, text field style, then roundboard text field style. You simply type and hit tab button, then you can take it. So that we have a paddings, so a little bit of the gap between this. And after this buttons, if you want to make it a little longer ones, wider space, then you can make a spacer, then a little more, because it goes all the way up, because you want to make a spacer, right? If you want to make another space here, so a little bit in the bottom. You have a spacer here above before you make text field, and after button there is also spacer, right? So here, hello, again, and echo me, then because there is a spacer, hello again appears bottom, right? After this hello again, if you want to make a spacer again, you can do that, then little above that. So hello, Mr. Morsi, echo me, then there's a space, another space, and another, so 3 spaces. Like here, we have a spacer, second spacer, and third spacer. you can declarate the button, for example, background color and foreground color. Then background color say blue, and then foreground color, oops, let's say foreground color here. So color, maybe you can say white. So you have white, something like that. Text again, yeah, something. You can make dot, then you can see multiple of those options. Then you can choose foreground style, italic, strike through, text scale, more underline, frame. So many can be attached to that dot notation. Okay. So now we exercise simple practice in both UIKit and SwiftUI. What do you think? How do you feel? Those two.
It's good.
Which one you think you like at this point?
I like SwiftUI more controls.
Yeah, SwiftUI is by editing a little bit, everything can be changed. UIKit easy to start and it's like fun, but change is not really simple. So like you guys, developer, SwiftUI. Therefore, I want you to taste the difference a little bit from the beginning. So we need to stick to SwiftUI. The homework assignments that I posted already, I want you to do this. So two things. One project for UIKit, another project for SwiftUI. So when you have done this and go to that folder, then you will have this UI SwiftUI and echo. This is that I asked. Okay, so you need to submit this and these two files, right? So what you need to do is you need to make a compress for each one separately. So echo SwiftUI, and the next one is a UIKit, another compress. So you need to submit these two compressed files, zip files. Okay, that way I can emulate it. If you submit any subset of those, then I cannot emulate it. Any other question before we